Hi everyone. So in this video, what I wanted to do is sort of go through the marking criteria for the Maths IA. And this will be applying to both SL and HL level, but you'll notice there's one subtle difference between the SL and HL syllabus, but the rest of it is pretty much very, very, very similar. So I think that if I go through the marking criteria first, it would be good to sort of know exactly what the markers are looking for. Because in my next video, I'll be covering the actual structure of the IA and how my suggested structure will accommodate these separate syllabus dot points that are outlined in the marking criteria. So let's get into it. The overall overview is that there are 20 marks up for grabs, and that is split across 5 criteria. We have presentation, which is worth 4 marks, mathematical communication, which is 4, personal engagement, which is 3, reflection, which is 3, and use of mathematics, which is 6. Now, criteria A to D are the same for AA and AI, for SL and HL. So SL and HL, regardless of the maths you're doing, for presentation, mathematical communication, personal engagement, and reflection are all the same. That's the same criteria. The only difference between SL and HL levels is criterion E, which is for the use of mathematics. Other than that, they're roughly looking for very similar stuff, SL and HL level. Now here is a rough outline of the marking criteria. And what I have done is I have written down the top criterion for each section. So to get 4 marks presentation, it says you need to have an exploration that is coherent, well organized, and concise. And then for mathematical communication, it has to be relevant, appropriate, and consistent throughout. And what I've also done is on the left-hand side, I have shown how many marks each thing is worth. So for presentation, the 4 cells that are marked orange, that means there are 4 marks up for grabs. Similarly, for personal engagement, 3 are marked orange, that means there are 3 marks up for grabs. And for each one, I have only included the top criteria for each one, because I believe that is what you should always be aiming for any assessment where possible. You should always be trying to aim for the 4 marks. Generally speaking, it probably won't happen. And that is completely fine. But I think it is always best to try to aim for the best you can, and then just sort of learn from where you may have not ended up actually reaching that goal, in my opinion. So I've included the top criterion for each one because I think that's always what you should strive for. Now, the only top criterion I did not properly include was here for the use of mathematics, and that is because it is different for SL and HL level, and I'll go through what their actual top criteria is a bit later on. So this is just a bit of a summary slide for you to refer back to if you wanted to, but I'm going to go through step by step each of these separate criteria to sort of discuss how you can get that top mark. So the first thing we have is presentation. Now that's worth 4 marks, and the top mark requires you to have an exploration that is coherent, well organized, and concise. So coherency, or having coherent exploration, means that it should be logically developed, easy to follow, and it meets its aims. So you need to lay out some aims within your internal assessment, and you need to show how your exploration goes from point A to point B to C to D, and how all of that helps in leading to you to achieve that aim. If you go on random tangents that don't go anywhere, you are not going to do well in this criteria. So that is what it means by coherent. It needs to be clear where you are going from start to finish. What is the point of each step you're doing, and how does it directly contribute to your exploration and its value? Now, this is also important for where you need to reference all your ideas. If you're just pulling stuff out of thin air or from a website that you have not properly referenced, that will not make it coherent. It'll be very unclear where you got that idea from. So you need to also, very importantly, reference all the things you get, and that should be through either in-text referencing or footnotes. Now, for a well-organized IA, this is where, in your introduction, you explain what your aim is. Some IAs will not actually outline what the aim is at the start, and it is very confusing to figure out where it's going, or why is it doing what it's doing? What is it looking at now that? So you need to set the scene well in your introduction and outline what your aims are right at the start. Say, this exploration aims to achieve, or to model, or to explore, or whatever. You need to outline what that aim is. Now, what you also need to do in well organized is you need to include appropriate figures and tables that accompany the work. So you should not be throwing in figures that don't directly contribute to your IA. And it should also be directly referenced in your writing. So you need to say, like if you throw in a graph and you call it figure 1, I don't know, modeling of whatever, in your actual body, in the typed up part on the side, you need to directly reference that figure and show and explain or show how that directly contributes to the working out, or how it helps explain the aims that you're trying to do. Similarly, for a table, you need to also say table 1, label it, and then reference it directly in the actual written part of the IA. What you also need is a good conclusion. At the end, you need to examine and say whether or not you have addressed that aim that you outlined in the intro. So you have your intro, which outlines all the aims and sets the scene. You go through all the maths, and all that maths should be well organized to help contribute to achieving that aim. And then in the conclusion, you need to outline whether or not that aim was achieved and to what extent it had or had not been, and all the shortcomings or anything like that. What you also need is an appropriate use of appendices. Now, appendices, generally speaking, is not something that markers will necessarily read and mark, but it is important to have for certain people. So let's say I had a statistics IA and it had a whole heap of data. That heap of data is not helpful in the IA, in my opinion. If it's like thousands and thousands and thousands of data points, you need to throw that in an appendix, because that is not directly necessary. But you can say data in your actual body or inside your intro or whatever, you can say the data was taken from Appendix A and was transformed into, I don't know, a scatter plot or something like that. And then you show the scatter plot, the visual summary. So the actual data itself, the raw data that isn't being processed or anything like that, that can be thrown in an appendix. Similarly, if you're repeating a lot of steps in terms of calculations, those repeated steps can be included in the appendix, and you can just put the first set of working out in the actual IA. That way it's not just repetitive and unnecessary stuff. The appropriate use of appendices. An inappropriate use would be if I couldn't fit all my stuff in my IA, I couldn't fit my conclusion, so I put my conclusion in an appendix. That is not the right thing to do, because that will not be contributing towards the graded stuff. The appendix is just meant to be something for the marker to refer to if they just want to check like the working out or the general stuff that you have outlined in your IA, just in case, basically. It is not something for you to try to fish for more marks with, if that makes sense. Now, another thing is conciseness. And that means that everything you include directly contributes to your aim. So that means you should not be having any irrelevant calculations or unnecessary calculations. Now, unnecessary is what I was saying before, where if I'm doing the same process like 20 times, I should only be showing that process once and then saying repeating this process for XYZ, instead of just showing that repeated process 19 more times. That isn't helpful, because the working out should be very much exactly the same if I am repeating the same process. Just the numbers might be different or something like that. Similarly, do not include unnecessary graphs or descriptions or anything like that. So if you're not directly referencing a graph, or it doesn't at all contribute to your aim, do not include it. There is no point in having a graph that does not contribute to the aim that you have outlined. Similarly, descriptions. If I just start going on a tangent explaining some kind of theory that I ever end up using, no, that is not concise, so I would lose marks for doing that. The next criteria we have is mathematical communication. Now, to get top marks for that, the mathematical communication needs to be relevant, appropriate, and consistent. So, a very important thing is using appropriate notation, symbols, and terminology. And that is what I was saying about how you should be using Microsoft Word, the equation mode, or LaTeX, or anything sort of like that, which makes it look more mathematics. And that means using the actual times symbol instead of an asterisk, or using an actual fraction instead of the slash. All those kind of things would be using appropriate notation. There should be other things, like if we're doing exponentials, it should actually be like 2 and then a little, if I had 2 to the power of 5, it should be 2 and then a little 5 at the top, like an actual power, instead of 2 and then the little pointy up thingy that sometimes is being used. Basically, you should be writing it out as if you were writing like things on paper in an actual exam. That is the notation that should be used. And I will go in a future video about how we can use equation mode to sort of make things look more professional and help achieve this criteria for mathematical communication. Now, another very important thing is you should be defining all key terms and variables. So if I throw in, I don't know, y equals mx plus b, and I do not explain what y, m, x, or b are, I would not do well. You need to say, if you're going to outline a formula, you then need to say what each individual variable means. You need to explain that. Otherwise, that variable could be absolutely anything. Another thing is you need to also define all key terms. Any new ideas that have come from your research, your respective math syllabus, you need to explain what that is. And then sort of put that in the context of your mathematics. Now, what they also want is they also want you to use multiple forms of mathematical representation. That involves formula, diagrams, charts, graphs, whatever. So in terms of that is just sort of saying using whatever is appropriate for your IA. So let's say I am doing a calculus IA. Like I'm doing an IA and it involves a bit of calculus. I'd be including stuff about derivatives. I'd probably be including maybe graphs, all those kind of things, maybe sign diagrams. Those kind of things would be appropriate and multiple forms of mathematical representation. However, if I am doing calculus, it's unlikely that I'd probably be including maybe a scatter plot or, I don't know, graph theory. It's unlikely. It could happen depending on your IA, but don't include anything that isn't unnecessary. Include the best representation of your work that is possible. If you think it's easiest to demonstrate like a path through a graph, draw a graph. That's the main thing that they're looking for here. Now, another thing that's very important is you should be showing all your working and ideas logically. So that means that you shouldn't have writing all over the page. It should be going down the page very logically, easy to follow. And you should be including all the necessary steps to make it very clear how your working has gone from point A to point B. You will not do very well, in my opinion, if you just skip the top step and the end answer, because then they don't know what process it has. You should at least, at the very, very least, have a statement saying what you have done. If you've just put it through a calculator or used technology, you can do that. Of course, that's fine. But you need to say using this technology. So you always need to lay out how you got the answer that you have. Otherwise, if you wanted to show actual step-by-step working, you need to show those steps. I need to find Spearman's correlation coefficient as part of my hypothetical IA. In that case, I would need to have the normal data. I would need to have the rank data. And then I can say, oh, and here's a scatter plot. Here's me finding the Spearman's correlation coefficient. Here's the answer using my GDC or something like that. So in that case, I've just shown step by all the individual steps. I didn't just show the normal data and then go straight to the Spearman's correlation coefficient. That would not do well. So you need to include all your ideas and working and explain it logically. You need to also put into context what you're doing and why. So I would be like maybe, I don't know, I will now differentiate this to find the minimum value for this value. And then you would go through all your steps and then say, hence, I have found the minimum value is, and then show that. That is logically setting into context all you're working out. And you're explaining a purpose for it and an outcome. Now, the last thing I want to say is you need to label all diagrams, tables, figures, and equations. Equations is an important one. And this is especially more for the algebra-based ones, where you need to sub in a lot of things back into each other or do simultaneous equations. If you label like the final answer, something like, okay, let's say we had something like, 5 equals 2x plus 3y. And then I had another equation, which is 7 equals 5x minus 5y. In that case, I would label the first one as equation 1 and the second one as equation 2. Then I can have a little statement saying solving equations 1 and 2 simultaneously. And then you get your answer, and then you can call that equation 3. So that is a very important thing, labeling all your equations. That way it's very easy to follow what you are doing and why. Similarly, if I introduce a big formula and I want to sub things back into that formula, let's say I had E equals mc squared, which is a physics idea, and I sub in stuff into that. I would need to label that formula as equation 1, then all the other stuff later on, I would say subbing this into equation 1, or subbing it into equation 1, anything like that. That would be very, very important. Labeling all your equations, so it's very easy for the marker to just flick back and say, oh, yep, that's equation 1. I understand where this person's subbing the values into now. Now, the next thing is personal engagement. Now, this is a bit of an interesting one. This is where they're looking for top marks, evidence of outstanding personal engagement. Now, that is a bit of a vague idea. So in terms of personal engagement, this is where like your independent voice as an explorer in mathematics sort of kicks in. So this is where it is clear that you have made efforts as a student to make an independent mathematical investigation. That means you should not be just copying a proof that a textbook or website says or anything like that. If you're just regurgitating other people's work, you will not do well in personal engagement. So you need to do something in your IA that introduces something new to the table. You need to be doing something that you yourself envisioned and achieved. You can use websites and technology and anything you want to support it, but the way that you are putting everything together is uniquely your own work. So you need to create a new idea or perspective and effectively explore it. If you do that well enough, you will do well in personal engagement if it's clear that you are doing something unique. So here are a few suggestions for sort of doing that, because I know that's quite a daunting idea. Try to explore maybe a common idea from a different perspective, or maybe test the validity of that old idea. Similarly, you could have a new idea and say, oh, I'm going to try this new method and compare it with a much more established one that has already been done before. Another idea is that you could be creative with sort of approaching stuff. Try something completely new. Maybe mix in areas of maths that haven't really been done before, or anything like that. Now, another big one is making a model or making a prediction about something and then trying to test it out in real life. Now, common ideas, maybe in a sport that you play, you could try to model your own behavior using some kind of mathematical expression, whatever you want. And then you can maybe try to test it out. Like, let's say I wanted to find the optimal way to throw a basketball into a hoop, or the optimal way to ski down a slope. I'm just making this up off the top of my head. If I sort of made a model of that, then maybe I could try to test it out by recording myself or testing out how successful I am in each of those things. If you do that, it shows that you are trying to bring stuff yourself to the table. If I recorded myself throwing basketballs into a hoop or trying to ski down a slope, that is personal engagement, because it's clear I am doing stuff practically myself that is enhancing the value of this investigation. So that is personal engagement. The next one is reflection. Now, to get top marks for this, you need to have substantial evidence of critical reflection. Now, that means you need to analyze and evaluate the exploration. Now, I think a lot of this tends to happen in the conclusion, but a lot of it can be inherent throughout your IA. Now, throughout the conclusion, though, this is the main part, you need to talk about addressing the aims. So, as I may have said in the presentation criteria, one important thing was your intro outlines what your aims are. Now, in your reflection, at the end of your IA, once you've gone through all your investigation, done all your mathematics and all the heavy lifting, at the end, you need to address, were my aims fulfilled? Why were they? Or why weren't? How could I have done better? And what did I learn from this experience? What was the new thing that I have learned? Maybe I have learned that my new technology, my new approach to something isn't perfect and it didn't completely encapsulate what I wanted to do. Or there is still, it's a bit rough around the edges or needs to be fixed up. Or maybe you could just say, oh, my idea is perfect but yeah, that's very unlikely. But yeah, this is where you sort of just address to what extent were your aims fulfilled? Why not? And what did I learn? Now, another important thing is you need to also talk about the implications of your findings. Let's say I tried a brand new technique and it brought about a new perspective on something. You can then say, hang on, this has brought a brand new perspective on climate change or whatever it is you're looking at. And then you can say, this maybe can be applied in future study, or this demonstrates how, any of those kind of ideas about how is there anything new that your IA findings bring to the table in real life? So there's implications on yourself or others. So maybe you could say that if you found an optimization IA or something like that, you could say, oh, I have learned that if I did this technique, it is better for performance. That is the implication of it on yourself, or anything like that. Or for others, anything like that. Now, you also need to go through strengths. So this is where you go through the relative things that went well. Maybe saying I controlled for all of these variables, or it seemed pretty accurate from real life testing, or anything like that. Just sort of go through any of the strengths you have. Now, the one that a lot of people find more challenging to write about is the weaknesses. Now for weaknesses, this is where you sort of discuss the shortcomings of your IA. This is where you sort of discuss a few important things. And a few of those would be maybe the IA wasn't completely accurate to real life, or you didn't account for certain variables, or, like there's a lot of assumptions. All of those kind of things are considered weaknesses. And that is completely fine. You are perfectly fine to have weaknesses. Remember, this assignment, I know it sounds like a lot, but 20 pages in terms of a mathematical investigation is not actually that much in real life. So you need to acknowledge that the scope of your investigation will be limited. You will not be able to account for everything in real life. It'll get really, really complicated if you do. So that is where you sort of discuss what are those limitations in the scope of this experiment. And generally that'll be having a lot of assumptions, or having alternative approaches that could have shown new things. All of those kind of things are considered very, very legitimate weaknesses, and they are completely fine to acknowledge. And I very much suggest you do well in these reflection marks. Now, another idea is you also should talk about areas of further investigation. Now, maybe you could say, hang on, one variable that I didn't account for was whatever it is. And then a future investigation would be examining how much this variable that I didn't account for could actually contribute to whatever I am measuring. That'll be a decent area of investigation. You could also talk about the implications of your findings for future research. Maybe you created a new model, but you want to test it out for people of different heights and stuff like that. So let's say I had an optimization model for myself and playing basketball. Now that optimization model might be very good for me, but might not be very good for someone taller than me. So this is where you sort of discuss, okay, here's what I've found, but we should be testing it more for other things, other variables, other people, all those kind of ideas. Those are areas of future investigation. And this sort of links closely to the last thing, which is the consideration of different perspectives. And this is sort of where you think about how maybe economists might be able to apply your knowledge, or sportsmen, or mathematicians, or climate scientists, or anything like that. All those kind of considerations of how your findings might contribute to later literature, or how it might even lay a groundwork for more research in future. Now, the last criteria is the use of mathematics. Now, that's worth 6 marks. That's worth the most out of all the different sections. Now, first of all, let's go through what is in SL. Now, at SL, the top marks are relevant mathematics, commensurate with the level of the course, and the mathematics is correct, and thorough knowledge and understanding are demonstrated. Now, first thing let's discuss is relevance. So this is similar to what I was saying in the presentation criteria, where all the maths you use directly contributes to the development of your exploration. So directly contributes to helping you achieve that aim. So that is why I was saying it's important at the start of your IA to have a little bit of a plan section as part of the structure. If you have a little bit of a plan section, you can outline exactly your starting point and all the intermediate steps quickly about how you intend on achieving that aim at the very end, and how each of those steps directly contributes to that. So that is making sure that all the maths you use supports the development of the IA. It's important because it shows what you are doing and directly contributes to achieving that aim. And also is using appropriate techniques. So let's say it was very clear that my data follows a exponential model. It probably wouldn't be appropriate then for me to use a linear model to reflect that. It's basically about using the appropriate techniques. That is also a very important thing to consider. Now, another thing is commensurate with the course. Now, commensurate basically means it is at the same level as the course. So if you're doing SL maths, your maths should be at the level of SL. You don't necessarily need to go beyond the syllabus in terms of difficulty, but you won't be penalized, but you won't necessarily be rewarded too much for it either. So I would say try to keep it at roughly the same level of difficulty as the level you are doing. Now, you also need to demonstrate this, which is very important. So you might have some really good ideas and really good mathematics, but you didn't show it. How can they mark you well then if you haven't shown the actual steps? This is where the demonstrator criteria comes in. This is where you show all your working out. And this is how you show that you did all this yourself and you didn't just, get someone else to do it, give you the answer or something like that. So this is where you demonstrate that this maths is you doing it. And of course, I'll once again say this is a different idea to getting your GDC to do it. It's completely fine to get your GDC to do stuff for you and say that the GDC did it. But there should still be an element of critical thinking and applying all those ideas. And you need to show how those ideas are being applied properly. Now, the last thing that they have here is being thorough. And that basically means, for the most part, trying to be correct. Now, you should pretty much try to be as correct as possible. I believe there's a teensy bit of leniency if you make very minor mistakes, but where possible, just avoid it. Try to be as correct as possible. That is pretty important, in my opinion. And you also need to show an understanding of your ideas and the mathematics and the reasoning for all the working. If you can't explain why you're doing something, that isn't thorough, because they might just think you're copying that off Wikipedia or a textbook or anything. So that is why you need to explain all the steps that you're doing and showing how that's important. Now, I've also included this slide, which is just the HL criteria. So the top marks is slightly different to this section here. Relevant mathematics can measure it with the level of the course, and the exploration is precise and demonstrates sophistication and rigor. That is different for the HL course. Now, thorough knowledge, understanding are demonstrated. That's pretty much the same. Now, when you're doing commensurate with the course, in this case, that means you have to be doing at the level of HL. Now, for HL, they also encourage, if you want, getting slightly above the level of difficulty, but once again, it might not necessarily be rewarded, but it won't be punished. Now, you also need to be precise. Now, precise is where they're going to be a bit stricter about errors. So you pretty much need to have no errors if you want to do well in this criteria. Now, you also need to have an appropriate level of accuracy, and that means having consistent levels of significant figures, all those kind of things. Just trying to be as accurate as you can if possible. Now, what you also need is a level of sophistication. Now, that means that the level of maths should be at a higher level than if you were doing an SLIA. So that means your maths should be at the level of HL, or it should be a much more complicated or sophisticated application of SL content. So you can do HL maths and you do an IA. Your IA can use SL maths, but it should be a much more complicated application of it. That would be much more appropriate in the HL level of maths. Now, that means you should also include, in my opinion, challenging mathematical concepts. And maybe that could be looking at how, optimization is applied to a real life context, maybe like wind resistance or something like that. Applying a new mathematical concept or a challenging one and seeing how it works in your IA. And if you can demonstrate a good level of understanding for that, they would love that. Now, you should also be trying to look at problems from a different perspective. That's also a level of sophistication because it's got that personal voice and it's doing stuff with that is more complicated and shows more engagement. So you can see how a lot of this criteria sort of cross over a lot. But HL, they've just got a lot more expectations of you. They expect you to do something more groundbreaking than like an SLIA. So please be wary of that if you're doing HL. You also need to recognize underlying structures that link different topics together. So like if you wanted to look at, discrete mathematics, or if you wanted to look at calculus or differential equations, you need to sort of look at how certain underlying structures could actually link the two ideas together potentially, and maybe in a brand new way that is innovative and hasn't been seen before. It is entirely up to you. It's just something that you need to try to set out to achieve. Now, you also need to have a level of rigor. And that means you need to have clarity of logic and language in arguments and education. That means you need to be very clear with what you are doing, and it needs to have a good level of foundation. And all your claims should be justified and proven. That is very, very important. If you're going to make a big claim, you need to justify it somehow. So, what's next? I know that was quite a daunting video, probably a lot to go through and a lot to consider, but don't panic. That's the main thing. Please don't panic. I know there's a lot to consider, but it should be okay. What I think you should do is, after watching this video, you should just brainstorm ideas for the investigations with this criteria in mind, considering what they are after. So I outlined how I suggest looking for topics and research and shortlisting in my previous video. Just keep that in mind over here. Also, stay tuned for the next video where I'm going to be going through an actual structure. I'm going to be deconstructing all of that skeleton structure I had given previously. And yeah, I also suggest keeping a printout of the criteria. Now this criteria I'm talking about is this one here. This is the summary I have made, but I've only included the top criteria. You can go on the IB website and find the full actual criteria with all the intermediate steps, but otherwise you can keep this one just on you. But I always suggest when you're writing your IA or planning or anything like that, keep a printout of that criteria with you, and so you know exactly what they're looking for. And yeah, once again, I'll reiterate, don't panic. I know that this is a lot to consider, but just do your best. Just sort of think about it. It's always better if you can try to pursue something that you're interested in, because that'll make you more motivated to keep pushing through it, because I know this is quite a challenging IA to write, in my opinion. But yeah, other than that, thank you for watching. I'll see you all in the next video.